Hey everyone, welcome back with a new lecture with quality control for chemical analysis. In this lecture, I will explain case study relating to systematic error due to systematic method error in liquid chromatography mass spectrometry analysis of sulfonamides in meat. You have a method for analysis of sulfonamides, veteran drugs, in meat using LC mass. That error was the method consistently underestimate the concentration of sulfonamides in fortified samples. You have quality control samples. From these quality control samples, you have the spike sample. And this spike sample or fortified sample with known concentration, you get unaccepted result. As example, if you spike 50 BBB and you got 20 BBB, as I explained in the previous lecture. So now recovery not within acceptance range. In this case, this error, you should make investigation to know from where this error, then you can fix, because it's consistently. So this is systematic. It will happen every run and also will affect every sample in every sequence. First reason came to my mind was matrix effect. There is an effect from matrix interferences on target analytes. You have matrix like meat which contain fats and proteins. It may suppress the concentration of target analytes, and you should take care of this when you develop your method. So the method does not account for ion suppression caused by co-eluting components such as fats and proteins in meats. These co-eluting components affect or suppress the concentration of target analytes in fortified samples, and then it will also suppress the concentration of target analytes in all routine samples. What will be the impact and how can you make solution for this? The impact or the effect of this issue: matrix effect cause reduced ionization efficiency in the mass spectrometry. When you analyze your matrix which contain fats and the proteins, and you cannot eliminate or reduce these interferences, for sure if you run these samples on the instrument, it will affect or reduce the ionization efficiency for mass spectrometry, and so the signal intensity will be lower. Then it will underestimate the concentration of target analytes in the matrix. Matrix effect cause reduced ionization efficiency in mass spectrometry, leading to lower signal intensity and will suppress the concentration of target analytes. And that will be every run. This is systematic. It will happen every run because your method cannot reduce or cannot eliminate the matrix effect. That will be every run because the developed method from the beginning does not address the matrix effect. So this is systematic. The solution for that error: first, you can introduce matrix magic calibration curve by spiking the sulfonamides into blank meat matrix extract, and that will be explained in a specific lecture. Also, you can use isotopically labeled internal standard for each analyte to correct for ion suppression. You will have internal standard for each analyte that will correct for ion suppression, and that also will have another lecture. And very important internal standard how to use to calculate the concentration of unknown target analytes in the matrix. And also the easiest way, you can add one more sample which is a standard matrix sample which contain the same concentration as the spike sample, but added or fortified at the end of your extraction, and calculate correction factor. Then this correction factor will be multiplied to the spike sample and also other samples. All of them will be explained in different lecture, but that was the solution for matrix effect error. When I investigated more, I found another problem: incomplete recovery during solid phase extraction cleanup. During solid phase extraction, you will use washing solvents to transfer the matrix interferences outside and retain only the sulfonamide compounds on the surface. So you need to retain these sulfonamides on the solvent. Solid phase extraction protocol used a solvent which does not efficiently retain all sulfonamides. Maybe this solvent not suitable for target analytes, and also under the specified pH condition. So another problem, maybe two problems: the solvent not suitable or pH of the washing solvents not fit or not suitable to retain sulfonamide compounds and transfer other matrix interferences. So in this case, the impact or the effect of this issue, it will reduce the concentration of target analytes because you cannot extract all sulfonamides. So we have the impact, consistent loss of certain sulfonamides during extraction, leading to, for sure, lower recovery and biased results for all samples. So this is systematic because that will affect all samples you will analyze, and you will know that from the quality control samples. The solution for that, you should optimize the pH of washing solvents. pH should be changed. You should try different pH, or you can read from publications which pH is suitable for your target analytes, and you can optimize the pH of washing solvents and extraction, and then you can transfer all, you can retain all sulfonamide compounds, or you can use a suitable solvent for that. That for improved analyte retention. And for this issue also, I have faced another problem with another method for analysis of tetracycline compounds in chicken. When I developed the method, I used simple extraction solvent. It was methanol 98%, 2% HCl, and I started analysis of replicate analysis, and I found recovery not good. Then I started searching for publication. I found that these compounds should be extracted in pH, acidic pH, but pH 4. So I don't need very strong acid such as HCl, so I used formic acid. And I also decreased the amount. I used 70% methanol and 30% deionized water, and I used formic acid. I adjust the pH up to 4. So pH now is okay. I found pH okay. pH should be 4. Then after that, when I started analysis, replicate analysis also, I found still problem. The result was okay, but I found still there is a problem. So I started again searching for publication to find out what could be the problem. Then I found that tetracycline compounds have a chelation with heavy metals in the matrix, with heavy metals in the matrix. So I need to break or remove or stop this chelation to extract only tetracycline compounds. And to do this, I should add another chemical compounds. I added EDTA, ethylene diamine tetraacetic acid. And EDTA will react with the heavy metals and will be taken out. Then I will extract only tetracycline compounds. So I can now extract all tetracycline compounds or most of them, then matrix effect will be reduced in this case. So very important during development stage to try many things and to read in publications too much. Then you will find always some problems to be solved, because after that it will be difficult to go back to the development stage. After you do for long time, to develop for long time your method, then you cannot go back again to the development stage. It will be difficult for you. So you should take too much time in the development stage for any method to reach at the end to the method which is fit for your purpose and fit to extract your target analytes and remove or eliminate or reduce the effect of matrix on target analytes. This example combined the two issues that I have explained. Another issue also in the method I found, which is improper calibration standard preparation. Calibration standard preparation is easy, you can prepare easily, but the issue was that calibration standards prepared in solvent methanol, not in the matrix, but still there is a matrix effect, and that's explained in the first issue. So that's already explained in the matrix effect. How can you do, or how can you solve this problem? Another issue, inappropriate LC gradient program. LC gradient program is very important. In LC mass, LC gradient program also should be optimized. HPLC should be optimized to improve the peak resolution and increase the signal intensity. So LC gradient program does not fully separate some sulfonamides. It cannot separate some of sulfonamide compounds from interfering elements in the matrix. So in this case we have poor chromatographic separation, and that leads to overlapping peaks. We don't have good peak resolution. Separation between compounds is not well, and also misquantification. We cannot quantify all of our compounds because we cannot separate all of them completely. And in this case, very important, you should redesign the grading program to improve the peak resolution and increase the signal intensity. For this example, you can investigate more and you can find many problems, and that all should be during the development stage, not after that. If you did everything during development stage and if you gave more time to the development stage, at the end everything will be easy for you. Thank you, and see you in the next lecture with another case study.